Now, what is zoning? Well, zoning is like an access list for your storage area network. Zoning is a way we can limit which devices can see and communicate with each other on a storage area network. In order to use zoning, you have to have one or more fabric switches on your storage area network. Only devices in the same zone can communicate with each other. By default, a zone is deny all. Zones are commonly used to protect disk access from an undesired host. For instance, if two hosts tried to access the same disk, there is a chance of them corrupting that disk. This also reduces the number of devices that you might affect with a change to your storage area network. Let's take a look at the steps you'd need to follow to complete zoning on your network. First, we need to assign physical ports to a vSAN. Secondly, we would then need to configure the zones with each vSAN. So as you can see on the right, we have vSAN 2 and vSAN 3, each with different zones. We then need to assign the zones to an active zone set. A zone set is something that we use to actually push a group of changes to your switch fabric. Each vSAN has its own zone set. A zone can consist of multiple zone members. As you can see on the right, we have host 2 and disk 1 and 3 in zone C, while we have host 1, disk 1, host 3, disk 2, all in zone A. It's also true that members inside of a zone can talk to each other, but members in different zones cannot talk to each other. Like I mentioned before, just like an access list, we deny all, unless they are specifically allowed. Finally, as we've shown in the graphic on the right, devices can belong to more than one zone. Here's an example of a basic zone. On the right, you can see that I have two hosts connected to my network. They are connected by a fiber channel switch in the middle to a storage device on the left. Now, my zone allows the top host on the right to talk to the storage device. It also allows, in zone B, the host on the bottom to talk to the storage device. But as you can see, neither of these hosts would be able to talk to each other. So in this case, the disk port is a member of both zones, but the hosts are only a member of a single zone. Here's an example of what the CLI looks like when we go through and create a zone. First, any device not in a zone is a member of the default zone. Second, a physical fabric can have a maximum of 16,000 zones, although I've never seen that in real life. Third, the attributes you can use to zone or create a zone are things like fabric port worldwide names, or FWWNs, fiber channel IDs, and device aliases. As you can see on the right, port worldwide names are quite lengthy. Device alias names are when you associate a easier name or a nickname to a port worldwide name or something similar. So for instance, you can see in the bottom box that I've taken the port worldwide name ending in 00:06 and given it an easier name such as AS01. As I mentioned before, zones belong to a zone set, and zone sets are a collection of zones that we push to a fabric and they become active to enforce the zoning that we have defined. Only one active zone set may be active per fabric and per vSAN. Here is an example of some of the different items I can use to create a zone. First of all, my fabric port worldwide name, or the port on the switch, and the worldwide name associated with it. Second one would be my fiber channel ID, or the ID that is assigned to the device when it logs into the fabric. Third would be my port worldwide name, and this is usually the worldwide name of a device that is logged into the fabric. This is what I see most commonly used in networking and zoning today. Port worldwide names are very commonly used in zone sets to identify devices. And finally, you can actually use the individual switch interfaces as well. So if you want to use port 7/16 or port 2/1, you're able to do that as well.